Yes, please. Very good evening to all of you, and this is Aryan here. So this is my sixth lecture or sixth video on my CCNA subnetting. I have finished six videos, so kindly refer to that videos. And if you have any problems, then please mail me on my email ID, which is CSEmanit2015 Let's take a new interesting topic today, Supernetting. Before that, I like to just tell you something that I am going to start with my CCNA L plus. This is a new invention by me. CCNA Lab only. CCNA Lab plus, that is all the topics of CCNA labs will be covered by me, starting with IS, Intermediate State Routing Protocol in both Hindi and English. So we'll start with something which is called the subnetting. So subnetting, I have told you that subnetting is nothing but dividing a huge network into small networks or small subnetworks or small chunks or small parts, so that for better management, for easier management of the networks, so that I can avoid wastage of networks. Now, this is another a very important topic which is called the supernetting, or it is in routing terms it is also called as route summarization. The first thing you have to understand is that supernetting is opposite of subnetting. Now, opposite of subnetting means that in subnetting I had a huge big network and I was dividing that into small parts. But in supernetting it is opposite, means that I have small networks and that small networks will be clubbed into one super network. The small networks I have will be clubbed into one super network. So the first point I guess is clear that it is opposite of subnetting, and small networks are combined into large single network. Now, how this is done we'll see later on. The purpose now. Again, this is very important, and this is where sometimes people traffic. Why this is needed? I mean, I'm not understanding. First, you say that supernetting and subnetting are two different things, and supernetting means that if I have a huge network or if I have a small network, then that small networks are clubbed into one single network. The main thing is that it is done to make my routing table concise and precise, or in simple terms to make my routing table smaller. If I have six networks and six networks are small networks and are pointing to a location. Okay, so instead of having the six networks individually in my routing table, I can just have a route summarization of that six networks into a single super network, so that my routing table will have only one entry. Okay, this I'll do it in my CCNA Lab Plus, and I'll show you a practical demonstration of this route summarization and how route summarization is helpful. Today we'll look at the theoretical aspect of it and how it is done. The practical application is done in routing in protocols like EIGRP, where we have route summarization, and that too route summarization can be done on per interface basis. Okay, now I'll take an example and I'll show you with an example of how supernetting is done. I hope the idea is clear. Supernetting is nothing but this: if I have one or more smaller networks, then that smaller networks are combined into one super network. Okay, so if I have four small networks, instead of pointing to four small networks each, I will point to one super network. I'll take you with an example of this. I have a network 192.168.10.0/24, and I have another network 192.168.11.0/24. Now in my routing tables I will have the entry of these two. Okay, and these two entries will be sent to other routers also, but I just want to send the route summary. That is, I want to club this network and this network into one single super network, and I want to just send the route summarization. The procedure, the theoretical procedure, please try to make sure over here is the first step is that you have to make or you have to write the binary representation of the network. So I have written the binary representation of 192. This is 168. This is 10 and this is 0. Again 192, 168, 11 and 0. Now what has to be done is you have to just look at whatever is same in both the binary representations. That is, I want to plug these two networks into a single network. So I have to make sure, or I have to look at the same part and I have to highlight it. So this and this is same. Okay, not at all a problem. So just let me highlight it. Okay, done. Then I can see over here also that this and this is also same. So I highlight this also. Till here it is same now. Now this is very important. Please try to identify. 1, 2, 3, 4, 5, 6 and 7 of my 10 and this 1, 2, 3, 4, 5, 6, 7. Both are same now. So till here I mark it as red. The mask over here was /24 and /24, so I had something which is called as 255.255.255.0, and here also I had something which is 255.255.255.0. Okay, no confusion till here. Now what I have to do is in my subnet mask, whatever was the same part, that becomes 1, west becomes 0. Please try to make sure. Now whatever was the same part, that becomes 1 and the rest becomes 0. So I just try to count how many are same over here. 8 plus 8, this is 16, 17, 18, 19, 20, 21, 22 and 23. So now my subnet mask becomes from /24 to /23, and I hope this 23 how it has come, I hope this understood. And the same parts are all ones, the rest is zeros. Okay, so now my subnet mask will become /23 and my first network is always sent as root summarization. So for both the networks now I can send a single supernet as 192.168.10.0/23. So if I write this or if I send a summary of this, the other router will make sure that these two networks 192.168.10.0 and 192.168.11.0 have been combined into one super network, and the super network address is this. Now just a simple thing you can make sure is that when I was doing subnetting, always found or always this was happening, that was the the mask, the default mask that I was writing over here, or the mask that I was writing over here, was getting increased after doing subnetting. But in case of supernetting, it will get decreased. So the mask of the problem given, of the network given, gets increased in case of subnetting and gets decreased in case of supernetting. A very simple example in terms, and this is the example that I will tell you in my CCNA lab plus also when I am doing this. So this router, okay, and this router, there are two routers, and this router has 1, 2, 3, 4, 5, 6, 7, 8 networks. Now 8 small networks are there. So now root summarization or supernetting, how it comes into the picture. Instead of sending each and every network singly. What I will do is I will combine this network into one super network and I will send it as a route summary, so that if this router has to reach to any of these networks, it will just send to the summarized supernet address. So how that is done? The procedure is very simple. You have to just follow on the second of it. So 172 will be same for each and every one. 16, 17, 18, 19, 20, 21, 22 and 23. This has been just divided into binary representation, and then in terms of binary representation I am trying to find out till where it is same. I can make sure that it is same till 1, 2, 3, 4 and 5. So the next three bits which are not same. So this is a red line in between over here. So earlier my mask was 16. Now I have 3, 6, 7 and 8. That is 3 bits of mine are not similar. So my new network will be my new super network. But this is my super network. That is my 8 small networks have been combined into one super network, one superman now. Okay, so the address for that will become 172.16.0.0/13. I hope how this slash 13 is understood. The only point that you have to understand over here is that straight away the network should be converted into binary representation. The binary representation should be checked till the point it is same. Till the point it is same, it becomes all one, and after that it becomes all zero. I hope how this 13 has come. There might be some confusion over here. I tell you 172 is the 8 bits. So that 8 plus 9, 10, 11, 12, 13. Okay. So this is how it is there. And this, please draw this picture somewhere. This will, I will cover it in my CCNA Lab Plus also, and I will show you how summarization is done. Okay, and how helpful it is in networking, especially if you have such small networks and you don't want to have such small networks in your routing table. You have to just send your route summarization, which happens in protocols like uh, this OSPF. That all we'll cover later on. If at all, if you have any problem in supernetting also, then please, this is my email ID. Find the email and please provide your feedback also. Thank you. Yeah, yes, please. Very good evening to all of you. So this is my part 5 of submitting. Please watch my previous 4 videos so that you get an overall idea of what submitting is, why submitting is used, and how submitting can be achieved via host and via network. So today I have taken a very simple problem, miscellaneous problem on subnetting, and I'll just read this problem and then tell you how to solve this problem. So what this problem says that how will you tell if a given address is a network address, a broadcast address, or an host IP address? I told you that inside the network we have three important addresses. So inside any given network, small network, big network, any, we have three addresses. The first one is the network address, then we have the broadcast address as I have told you, and in between IP address is given to the machine. So what this problem is saying that if I give you this address, for example, that is 99.99.99.64 slash 27, it says that how will you tell me that the given address is a network address, a broadcast address, or a host IP address? Again, you will not find any kind of solution which I am providing anywhere. You search the whole YouTube, you search anywhere in the net, you will not find the solution which I am giving you. So kindly follow this procedure. What it is saying. So I have three addresses over here. The addresses can be any 99.99.99.67/27 and 99.99.99.95/27. So just to recap, just a small recap or a revision. Again, after the slash, we have something which is called as 27. So my network bit is equal to 27. Inside my IPv4, I have 32 bits. So obviously my host becomes 5. That is 32 minus 27. Host is equal to 5. Now 2 raised to the power 5. That is the host 5. 2 raised to the power 5 is equal to 32. And this 32 becomes my divisor. So just to recap or just to summarize what I have said is that in this simple problem we have three different addresses, and I have to identify, or you have to identify, if the given address is a network address, or it is a broadcast address, or it is a simple host IP address. The first thing I told you, that focus on /27, so n is equal to 27 and h is equal to 5. You will observe that in all my videos the pattern is same. Just follow this pattern blindly, and I am 100% sure that CCNA certification is not far. It is very easy. So 2 raised to the power 5 is 32, and this becomes the divisor now. Please try to remember, or please try to understand now. So I have got my divisor and I am marking my divisor with red. Okay. Then I have taken the first address. So the first address last octet is 99.99.99.64. So my last octet number, or my last octet decimal representation, becomes my dividend over here. So I have divisor and I have dividend. Just for your simple explanation, 12 divided by 3. So my 3 becomes the divisor over here and my 12 becomes the dividend over here. Then I have something which is called as remainder and quotient. So this is pure maths. So what I told you is the procedure to find out if an IP address, a given IP address, is a network address or a broadcast address or a host IP address. What I told you is that the 32 becomes the divisor and 64 is equal to dividend. I hope how I have taken the 64. The 64 is nothing but the last octet decimal number. Okay. Then what I am doing now is I am just dividing. So 64 divided by 32. 64 divided by 32. If at all the remainder if is 0, then this address, the provided address, will become a network address. I hope this is understood. If the remainder is 0, it becomes a network address. I have written over here. So the first address we have solved it. It is a network address, not at all an issue. The second address we have. The second address given over here is 99.99.99.67/27. Again the procedure will be same. N is equal to 27, H is equal to 5. So my divisor is 2 raised to the power 5, which is 32. 32 is the divisor, but the dividend changes now, and the dividend now is 67. So again 67 divided by 32, I am getting over here a remainder which is 3, that is 32 into 2 is 64. So 67 minus 64, the remainder becomes 3, and my quotient is also 3. From this I can identify that this is the third IP address. Of the third subnet. Now again this is very easy. So when I was solving the problem, if you can just check my previous videos, you will try to understand that inside this I had my first network address as 99.99.99.0/27. Then I had my network address 2 as 99.99.99. 32/27, and I had my third network address, that is 99.99.99.64. So that became my third subnet. Okay, 1, 2, and 3. And inside the third subnet, my first IP address will become 65, my second IP address will become 66, and my third IP address will become 67. So I hope this is so. This is my third host IP address of my third subnet. Then last one, there is an IP address which is given as 99.99.99.95/27. So again my divisor over here becomes 32 and my dividend over here becomes 95. 32. So 95 divided by 32 gives me a remainder of 31. So if now the remainder is 1 less, if the remainder is 1 less, then if the remainder is 1 less than the divisor, then that address is a broadcast address. So in this example you can make sure that the remainder over here is 31 and my divisor over here is 32. So if the remainder is 1 less than the divisor, this address has to be a broadcast address only. Okay, and from the quotient you can make out that this is the third subnet broadcast address. So this is what I wanted to tell about the miscellaneous topics for subnetting and how very quickly to identify which is a network address, which is a broadcast address, and which is a host IP address. All the things in subnetting that I have taught you in the 5 video series, because this is my last video series on subnetting, so I'm just telling you is that it will help you practically in each and every way. This will help you practically when you are in the industry doing things. All the shortcuts that I have told you, please practice it so that it will be very helpful to you in future. If at all, if you have any problems or if you are facing any difficulties, then kindly, this is my email ID. Please give me your feedback and as well as your suggestions, and if at all if you have any difficulties, please mail me on this number. Please mail me on this email ID with the csvmanic2015@gmail.com. Just so now I would like to tell you that one more video I have on supernetting, and with this I'll finish both subnetting and supernetting also for CCNA exams in a very easy and lucid way. And after that I will be starting my CCNA L plus. L plus is nothing but all the topics based on CCNA labs only, not theory, and this is a complete focus on labs, and I'm starting with labs based on ISIS protocol, intermediate state protocol. This is Arun Aryan signing off. Thank you.